it gets a little trickier. Now we can do perfect square trinomials. And a trinomial means that it has 3 terms. So those were binomials, that had 2 terms. So a trinomial means that it has 3 terms. So for example, x squared plus 8x plus 16. But if you notice that the first and last term are both perfect squares. Now, perfect squares have to have, so they're both perfect squares. So if you look here, obviously this is addition. So it's a perfect square. And I can take the square root of each of the first and the last term if they're both perfect squares. X and x, 4 and 4. And then we look at the middle term and it's a positive 8. So we know that they are both positive. Okay? So another example, perfect square, a squared minus 10a plus 25. So here we have perfect squares because a and 25 are perfect squares, and this is addition. So we know our operation, since it's a perfect square, it has to be the same. And so since it has to be the same, this one always has to be addition, right? Because a negative and negative is a positive. And so it always has to be addition. If this was ever a subtraction sign and they were perfect squares, it might be a prime where you couldn't factor it. You would have to use quadratic equation. But we'll get that in another lesson. But you just take the square root of a squared, so that would just be a, and then take the square root of 25, and it's 5. So if you notice, you have 2 binomials that are the same, so you can actually rewrite this as a minus 5 to the 2nd power. Okay, so this is how to factor perfect square trinomials. Let's do one more. 9y squared minus 10a plus 25. So again, we know that 9y squared is a perfect square. We know that 25 is a perfect square. This is addition. So we can put them into 2 binomials. Look at the middle term to see what operation. So it's subtraction. Take the square root of 9y squared. Well, the square root of 9 is 3. And the square root of y squared is just y. Then the square root of 25 is 5. Square root of 25 is 5. So we have 3y minus 5 to the 2nd power when we simplify it even more. Okay, now let's go on to just